Okay, you are welcome. Let's take a look at this question. Solve the linear differential equation x dy dx plus y is equal to x sine x. X dy dx plus y is equal to x sine x. And then let's take a look at this very carefully. Does this look like linear differential form? But the question says solve the linear differential equation. That is to say, even if it does not look exactly like the linear differential form, that means it can be arranged or reduced to linear differential form. Okay, good. So now let's go. Here we have x dy dx plus y equal to x sine x. Let's work on it and let's make it look like linear differential form. What are we going to do? We want to make dy dx to stand alone. For us to make it to stand alone, that means we multiply everything by 1 all over x, so that dy dx will stand alone. So when we do so, we're going to have x dy dx multiplied by 1 all over x plus y multiplied by 1 all over x equal to x sine x multiplied by 1 all over x. So here, x multiplied by 1 all over x is x all over x, which is equal to 1 times dy dx is equal to dy dx. And then we have 1 all over x multiplied by y equal to, in this place, in the right hand side where we have x sine x multiplied by 1 all over x. So this x behind sine x, we multiply 1 all over x, then we have x all over x equal to 1 times sine x equal to sine x. So here, after multiplying through by 1 all over x, we succeeded in making dy dx to stand alone. Okay, we don't want it to be associated with anything, and we succeeded. So here we have dy dx plus 1 all over x times y equal to sine x. We can see clearly that it is in a linear differential form. It is in a linear differential form. Now, looking closely, we see that p is equal to 1 all over x. We see that p is equal to 1 all over x. And then q is equal to sine x. Q is equal to sine x. Let's go further and find the integral of p with respect to x. That is the integral of p dx. So the integral of p dx is equal to the integral of 1 all over x dx. The integral of 1 all over x dx is equal to ln x. Okay, good. Now let's go further and find the integrating factor. The integrating factor says exponential the integral of p dx, or we say e raised to power the integral of p dx. We have solved and we have obtained the integral of p dx. So taking the exponent of it now is going to give us e raised to power ln x. So when we say e raised to power ln x, we are simply going to have x. We are simply going to have what? X. Good. So therefore, the integrating factor that we have now is equal to x. All right? Good. Our solution now is going to give us y multiplied by the integrating factor is equal to the integral of q multiplied by the integrating factor dx. Hello. Our solution is going to give us y multiplied by the integrating factor is equal to the integral of q multiplied by the integrating factor dx. And then our integrating factor is x. So x multiplied by y is going to have yx is equal to the integral of our q is sine x. Sine x multiplied by our integrating factor, which is x. And then dx. That is integrating sine x times x with respect to x. Okay, good. So here we have the integral of x sine x dx. Okay, good. So let's integrate x sine x with respect to x. You can do this using integration by parts. You get it right? Good. And then we have a very shortcut in doing it. We call it DI method. I have the video or the lesson in our channel. Please search for it. Integration by part using DI method is very simple. Okay, so now when we integrate our right hand side, where we have the integral of x sine x dx, it's going to give us sine x minus x cos x plus c. Hello. It's going to give us sine x minus x cos x plus c. So therefore we have yx is equal to sine x minus x cos x plus c. We want to make y the subject, so we divide through by x. So when we divide through by x, we're going to have y is equal to 1 all over x open bracket sine x minus x cos x plus c. And this is the solution to the differential equation. All right? Yes. Thank you very much. Let's take more examples. Stay blessed.